Okay. So what you're going to want is a formula sheet. So we have a new formula sheet today with our trig identities. Make it easier. Thank you. I also graded your test, so those will come back later. But chapter 5 formula sheet. That's today. Woo, formula sheet. All right. We'll eventually get to all of these, and it's going to be great. You left. Oh. All right. Oh, back one here. All right. There's a back. Oh my god.
There's.
You look this one.
That's my favorite.
I love this. Who is this question? Okay. Oh yeah, but we're going to become experts, so don't even worry about it. All right. So we're going to use basic trig identities today. So hopefully today feels a little bit more like it is review, because we're going to use things like cosecant is 1 over sine. Yeah. Cosecant. All right, so I have to figure out what computer I'm trying to press here. Okay. So these are the first ones that should be kind of near the top of your formula sheet. However, this one's in more of the display like the textbook. So on that note, we've got cosecant, secant, cotangent, sine. Cosine and tangent are the inverses of, anyway, okay, I have to flip of those, reciprocals, sorry. And then tangent, cotangent. So again, that's our first one. So again, that was the first two sections, that should be easy. All right. The next ones are Pythagorean identities, which when I first was introduced to those, I was like, you're kidding. So instead of a squared plus b squared equals c squared, it's actually cosine squared plus sine squared equals 1. And it does every single time. So then you can actually get these ones by deriving the first piece. So for instance, if I divide everything here by cosine squared of theta, because who wouldn't just sit there and do that? Yeah. Clearly, that's what I do on my day off. That becomes 1. Yep. That sine over cosine becomes tangent squared, and 1 over cosine is secant. Right? So you can derive each of these from the original phrase. And then if I divided everything by sine squared, that's how I would get this one. So everything can be derived from that. So for instance, when Henry came in Friday and yelled at me for not having him memorize the formulas, he clearly has this one memorized, and he can get the other ones from that. So he's making it seem like I should have you memorize all of these.
I'm glad you're not.
Except apparently when you come back and yell at me later. So.
Well, I'm not going to do
All right, well, hey. It's like your class around. So that's it. There you go. All right, then we should be able to get these ones as well, because we know, for instance, that if we take sine and talk about a phase shift of sine, you can get to cosine, yes? Okay, and that's actually what's happening here. So all of these are talking about how each of them are the phase shift of the other. So cotangent, for instance, you can get from tangent by talking about pi over 2 movement, and that's where all those come from. So everything is everything else by pi over 2. These ones will not come up as much as you would think, the cofunction identities, but specifically these two with cosine and sine, very helpful to remember that sine and cosine are the same, just shifted. All right. So that's that piece, and then we're going to do some magic. Okay. So here we go. So we're trying to simplify, and later on it'll be a little bit more direct, maybe, okay? Because it'll say things like equals 4, and you're going to show me all the work until you get to 4, okay? However, we don't have that yet. Those are actually trig proofs, okay? Right now, we're just going to simplify. And of course, your definition of simplify might be different than mine, but that's okay. We are trying to reduce as much as possible. So starting today, the biggest thing is to take anything that's not sine directly and cosine directly and make them into that, because then things will start to cancel. For instance, tangent is actually what with cosine and sine? Close. Sine over cosine. So I'm going to rewrite it as sine of x over cosine of x. And then you're going to remember that anything that doesn't have a fraction can actually be a fraction over 1. And so then we're going to say that this left side is over 1. And then the entire thing is actually a fraction. And so then we're going to cancel the cosines. And we're going to be left with sine. Yeah. So it's kind of like if you've ever seen that joke of the person that like wrote the speed limit, and then they like did some weird algebra in here to make 40 or whatever. Yeah, it's kind of like that. Anytime you want to write sine, you could just write cosine times tangent, but again, not really simple. So that's where that comes from. Okay. So again, simple. Hopefully your definition is the same.
So to simplify, we're just trying to get it down to cosine or sine.
Yes. All right. So now we get to remember a little bit more about our algebra, okay? For instance, that sine squared could be sine times sine, or that cotangent is cosine over sine. Or thinking back to the trig identity, there's something about a squared and a 1 in there, so maybe we could use that. So this is where this unit gets a little obnoxious, because you just kind of have to guess and check. So taking a look at all of these pieces, for instance, I see cotangent on the sheet, and the fact that it equals 1 over tangent, or cosine over sine. So I can rewrite the denominator first as cosine over sine. That's an X. So that's at least my first step. Cotangent is its own fraction. But then if you look at more Pythagorean identities, which is called altered from above, okay, hopefully you can see that if you rearrange a bunch of things, something equals 1 minus sine squared. And what is that 1 minus sine squared equal to? By a Pythagorean identity. Anybody find 1 minus sine squared on there? Yeah. So this actually equals cosine squared. So we now have cosine squared of x over cosine over sine, which also is weird, but a fraction over a fraction means that you could multiply by the reciprocal if you feel like it. Also, I feel like I haven't talked about this yet, but cosine times cosine is not cosine squared there, it's here.
Because it doesn't affect the x.
Yeah, because we don't want it to be over here, because then if you write it like they do, then is the x squared or is the cotangent squared? Yeah, versus if you always use the parentheses, it would be pretty easy to tell if it was in there or not. So anyway, cosine squared is actually a squared and then of x. So on that note, technically cosine squared of x is over 1, it's its own fraction. And so I'm going to rewrite this as the first fraction, the way it is, multiplied by the second fraction flipped. Right? So to divide fractions, you take the first, keep it that way, change it to multiplication, and then flip the second. Which will be nice because now this cosine will cancel at least with one of these cosines, right? And so now our simplified answer is cosine of x, sine of x. Which again, I don't know, is that more simple than that? It still has 2 trig, but it doesn't have a fraction anymore. So maybe that helps you feel a little bit more like it's not hard. Okay. So again, later on when we do proofs, it will come up with a phrase like this.
What?
Ooh, yeah, apparently I scared you there. All right. Later on when we do proofs, it'll show this equal to that, which we just proved that it was, right? We just did the algebraic process for that. And then you'll have to move, change one side to look like the other. But right now, we're just going to simplify with kind of what feels like no end result, like no idea of where the end is. So, sorry about that.
Oh, fine.
Exactly. Kind of trying to get it to sines and cosines. All right. So next one is using the basic identities to simplify the expression. So hopefully some of these pop out as things that you have on this sheet. So right now you should see if you can do this without me doing it.
I don't, you say so. Yeah, come on. I don't think so. What time was it?
There can be something. Better than that.
Yeah.
That's just sign. That's fine. Did I do it?
I don't know, what did you end up with? But then you're gonna want to rewrite that so that it's just sine and cosine.
Yeah.
Simplify a little bit more. So hopefully we know that cosine of pi over 2 minus x is sine, yay. Right, it is, the answer is just cosine.
Yeah, it would be,
Yeah, because this is cotangent, so that's cosine over sine. Yeah, and then you're multiplying two fractions, because it's technically over 1. And so then your sines cancel, cosine. Yay. I know, huh? What's that? Yeah, see, and that's why I'm reading that. So, here we go. I know, come on. All right, so this is kind of small looking, but I'm going to make it bigger. Maybe. Oh, yeah, okay. So again, looks a little bit strange, but see what you can do here. For instance, just to make it really exciting, I'm going to tell you right now that the answer is sine.
why would you do that to me? Now it's just a proof.
You can ignore the green if you want.
But now I know it.
And maybe, at least this is how I do it the first time that I was introduced to these, is I think of it as x cubed plus x times y squared. And how you might simplify that, because I am actually going to ask you to factor out a piece that's alike in both of them. Like, couldn't you take out an x from both of these? And then it's, well, yeah.
That's what I was thinking.
Yes, but x wasn't just x, it was sine, right? So sine, and then sine squared, and then cosine. And so there's sine, but then what was sine squared plus cosine squared? 1. Because it's a trig identity. It just is. Yes, you could actually prove it with the fact that sine is the height of the triangle, and then cosine is the base of the triangle. And then you could say with diagram theorem that base and then two legs squared plus each other equals the hypotenuse squared. Very exciting, because all of the unit circle triangles have a radius of 1. That's why we call it a unit circle. Oh, in her life. See, this squared plus this squared equals this squared. Yeah. Okay. So back to Pythagorean identity. Sine squared plus cosine squared, very exciting, equals 1. And so the answer is just sine. Yay! Which I already told you it was earlier, so. And Anna is having a flashback to chapter 5 that she doesn't
Oh, I like chapter 5.
like. Okay, see?
It's the only good part of PreCalculus.
Trig proof. It's the only good part. Yeah, I didn't. I just stole it. All right. Also, like all math curriculum is pretty much stolen, right? Since math was never invented, it was discovered. And anyway, okay.
That's what they like to say. It's stolen. It's the one that says 2 plus 3 is 5. It can tell you that.
All right. Especially if your definition of 2 is different.
Yeah.
Because 2 could be like 2.5 things. Anyway. All right, so this one is going to be another one of those scary algebra ones, okay?
Oh, great. Love the way you describe it.
So for instance, if we pretend that secant is x, and we want to take x plus 1, x minus 1, and multiply them? No? Yeah?
I have to write it down before.
With maybe the area model that we've done before? Yeah. Yeah, I know. I would say the box / area model. Oh gosh, I mean, I never said the word slash, but I would.
I've never
Oh my god, yeah, it's the area model because we even did those little like manipulative things for the squared guy.
Yeah, you just use the box. Yeah.
Yeah. Well, no, like we actually used the tiles when we were completing the square.
To create a box.
Right, but like the idea was that they had area lengths and widths that.
But you never said
In all
area
honesty,
model.
I got nothing out of that exercise.
I know specifically that one of the questions says use an area model, and everyone's like, what? And I just say, oh, the box.
Yeah, because you never told us what it's called. That's why we're confused.
Okay, so anyway, the box is actually called an area model. You're fine. So either way, this is x squared, which of course is not x, it's secant, but moving on. And then this is x, and this is negative x, and this is 1. Negative 1. So if we rewrite x plus 1 times x minus 1, you get x squared minus 1. Because combining the sides together will make 0 x's. So if I want to interpret this answer for up here, what is the numerator going to be instead? There you go, secant squared of x minus 1. And honestly, anytime, at least as you are right now, that you see a squared, you should pretty much imagine that it's a tangent, true Pythagorean identity. So, yeah, what do you think it is?
There's an identity for this.
Oh, what is it?
Tan squared of x equals secant squared of x minus 1.
Oh my gosh, so
Oh
tan
my God.
squared of x came from this under your Pythagorean identity. Uh-huh. Yeah, altered from above.
Oh.
The one in the middle on the bottom. So that numerator becomes tangent squared of x, and the denominator becomes sine squared of x. And then we get to do a little extra fraction math, because tangent is actually a fraction of sine over cosine. So sine squared of x over cosine squared of x over sine squared of x over 1 means that we are going to take the sine of x over, this is going to get a hand cramp. Yeah, and so then, wait, I didn't flip it. Oh, flip it, come on.
Oh, okay. I was like, oh.
I know, and you were like, wait, that doesn't make sense. There we go. And then, of course, instead of writing the answer as 1 over cosine squared of x, there is a way of writing that a little bit nicer.
Secant?
Yeah, secant squared of x.
I thought you wanted us to write that.
I know, but if there's a fraction, it might be nice to just keep it as one word. Yeah, keep it in fraction. Okay, so yeah? Yeah, I know. Just don't.
That's why he's the art teacher, not the math teacher.
Yeah, but I mean, look at this. This is art. Okay, moving on. Is that it? Is that the assignment? No. I feel like there's one more example and then the assignment. Yeah, so one more example, people. Let's see if we can do it. Oh my gosh. So probably automatically you see the squared, and you should immediately think there's some sort of Pythagorean identity there. Especially because there's a 1. If there's ever a 1 involved, there's probably a Pythagorean identity. Should be cosine squared, yeah. Yeah, don't you have it memorized? Go ask Henry. Okay. Now, this one's different because, oh my gosh, what's right here instead of multiplying? So now we need a common denominator, right? Or we could just simplify this first one, because then it will be common, right? There's actually 1 over cosine if we cancel one of them. But yes, there will be times where we need to make a common denominator, just sneakily this one's not it. Yeah, you multiply this one by cosine of x over cosine of x, yeah. If you wanted to get some more stuff to work in. Yeah. So let's say that we didn't do that, okay? And so now we're going to subtract them, which means that we're going to have in the numerator 1 minus sine squared of x over cosine of x. They don't make 0 or anything. And then you realize that 1 minus sine squared of x is actually cosine squared of x. And so it's cosine squared of x over cosine of x. And so finally, the answer is just cosine of x. So again, your proofs eventually will say that. And you're going to be like, seriously? But yeah.
Would it be 1? It would be cosine of x over cosine of x.
No, the 2 cosines cancel, so you get the 1 left over. So if you want to put it over.
Yes, that makes sense.
Okay. Anyway, so that's the last one of simplifying your expressions. So, do we have any other questions? Same identity used twice in that one. Kind of sneaky. All right. So your assignment is right here, and it's very much like this, except if you like press the button. Oh, there's the answer. Well, it's worked through. Okay, there it is. So, we're going to do page 451, numbers 9 through 16, and 23 through 38. And they're all going to use these super awesome identities. And then if you want to look ahead, the rest of them are later. So. Next time we have class, we're going to be doing the sum and difference identities. It's going to be great. And of course, these notes are filled in and posted on HeadRush if you would like to check them out.
I kind of forgot how that one.
Oh, yeah, that one's annoying.
That one sucks. Probably.
Oh, no, we know. Tangent is not fun. All right. Let's see.
What's a U?
What's a U?
Oh, yeah,